Are we live? That is the question. We are live. Okay. Hello, everyone. Welcome to this Tinybird live stream. So if you were expecting Jorge Sancha to appear, apologies, he won't be, but I will try and do my best impression and wave my arms as much as I can. So today we are going to look at using Tinybird to analyze your Kafka streams and turn them into scalable HTTP APIs. Now, I have a little application to build and a use case to run through, but I appreciate that some folks won't be able to stick around for the full stream. So I'm going to start with a little TLDR or TLDW, as you're not reading this. But we'll kick off with the highlights and then go into the full application and give some context around what Tinybird is and how it fits into your stack afterwards. So if you can't stick around, but you do want to check out what the use case was, the recording will be available and the repo with all the assets is on GitHub. Go and check it out. So very quickly, let's jump into the TLDR. So in Confluent Cloud, I've got two Kafka topics. I've got generation and intensity. Those are my two topics. And I'm going to connect those into Tinybird and build a quick API. So they've got about 5.5 million messages already in those topics. So I'll go through to cluster settings and copy my Bootstrap server details, and I'll come through to the Tinybird UI. So just as an FYI, the Tinybird has a free plan. You can go in, sign up, no credit card required, and start building straight away. So I'll go through and go to data sources, and I'll pick Confluent, and I'll paste my Bootstrap servers in, and I'll call that Confluent Cloud. And I've already got my Kafka key and my secret. And that's all I need. All my messages are in JSON, but if you are using Avro and the schema registry, there's a little box here you can tick and connect up your schema registry. So I'll hit next. That'll connect to Kafka, and it will discover the topics I have permissions to view. So I can pick the topic that I want to connect. I'm just going to start with intensity, and it auto-generates a consumer group ID for me. I'll just leave that as default. I'll click next, and then I can pick which offset do I want to start from. Do I want to start from the earliest or just the latest? I'm going to start with the earliest because I've already put some messages in the queue. I'll hit next, and it will go away, and it will take a little sample of data out of the topic and try and analyze that to work out what the schema should be. So it's discovered all of the names for the columns based on JSON, and then it's tried to work out what the type of each field should be. So if you don't like the types that it infers, you can hit the little three dots and change the types. For me, I think the defaults that it's worked out fine, so I'll leave it as they are. But I will give it a name, so I'll call that intensity. I think it was intensity that I picked. If it's not, I'll rename it. And I'll create the data source. And just as an FYI, you can tick and untick these columns. So if you for some reason you don't want a particular column, then you can untick it and it won't write that data. So I'll hit create data source. And that's it. My topic is connected. So I'll quickly do the second one as well. So Confluent, save my connection details. I'll pick that, and this time I'll choose generation, and next. And again, I'll start from the earliest. And again, I'm going to leave the schema just as it is default, but I'll give that a name, generation, and hit create data source. So that's my two Kafka topics connected. Now, the thing to note here is Tinybird is connecting directly as a consumer to your Kafka. So there's no external ETL tool, there's no schedules to set up. It is connected as a consumer group, and as you publish messages to Kafka, it is consuming them and writing them to Tinybird in real time. So once it's consumed a little bit of data, you actually want to start doing something with it. So we can create a pipe. So I'll just create a new pipe here. And a pipe is just a place for you to start writing SQL. It's standard SQL, so I'm not going to get too fancy with writing, a big complicated piece of SQL. You get the idea. It's SQL. You want to do joins, you want to do aggregations, window functions, whatever. It's SQL. So I'm just going to keep it super basic, and I'll do a count, right? Just pretend that this was something more complicated and good for your use case, and I'll call this my count. So I've got my faux use case logic, and it's in a pipe called my count, and then I actually want to I've got an application and I want to expose the results of that query to my application. So I don't have to do anything else. I can hit this create API endpoint button, pick the query. I didn't give the query a name, which is bad practice, but it's fine. I'll select the query that I've created and click of a button, I get an HTTP API. So I can copy this URL, open the tab, paste it in, and I get the results of my query in a HTTP API. So in this case, I've got it in JSON. All of the APIs are available in JSON, NDJSON, CSV, and Parquet by default. No config for that, you just change the URL. And all of the observability data about your queries and your APIs is available. So every request is logged, the latency of it, how much data it processed, all of that is available. Nothing else to do there. And every API is secured with flexible auth tokens. So that is pretty much the TLDR. So if you can't stick around, hopefully you get the idea of what we're trying to show. But please do go and check out the recording. So with the TLDR out of the way, I'm going to reverse a little bit and cover some of the higher level stuff of what is the use case we're actually going to try and build, what is Tinybird, how does it fit in your stack, how is it different. I have not been doing a very good job of checking chat, but no questions at the moment, so I think we're good. So what are we going to build? This is a little application that is consuming some data about the current energy generation stats for the UK national grid, which is our energy grid. So at the top here, we've got some stats about the generation mix, so what sources of production are making up the current mix. And down here, we've got the carbon intensity, which is the intensity of carbon emissions currently. So we've got some time series stuff at the top, and then we've got some individual metrics, which is just the very latest. And then down here again, we've got some time series and some metrics. So, you can imagine that these would be powered by HTTP APIs. If you were building this as a web app, which this is, normally you would, have a HTTP API that it would go and fetch that data from. Now, I'm not going to get into the actually, writing the JavaScript code on this stream and so I have pre-built that. It is live here, and you can see what the current state of it is, which is pretty much blank. So the framework is there, and all that's missing is the HTTP APIs. And as I publish those APIs, they should just pop in, and we'll see those appear. Great. So I would imagine that pretty much everyone has built this kind of application, a different use case, but this kind of application at some point in their career. a front end app that is trying to hit an API, get some data. You've got some data coming in, you've got a database, and then you've got to build an ORM and an API to translate the queries, and then your app. But generally, that has a lot of moving parts, and especially if you're getting into high scale enterprise level stuff, it can get pretty complex. So this is just a quick diagram of what that typical stack might look like. So hopefully it is somewhat familiar. Obviously, there's a million different variations of what this exact pattern looks like. This is just one. But typically, you've got some sort of event streaming thing, and that might be Kafka, PubSub. That's quite often going into a data lake. So you might have just flat files in S3 or GCS. You might have, Delta Lake or Iceberg or something going on in there. And then you might have a data warehouse on top of that, Snowflake, BigQuery, Redshift, something to do your actual analytics, typically BI style stuff. And especially recently, obviously DBT has become massively popular, and I'd imagine most people are probably using it to handle your actual modeling and shaping of your data over the warehouse. Now, quite often you'll also have something like Airflow or some other sort of scheduler that's triggering your modeling, but then is also probably doing scheduled exports from your warehouse into something like a low latency store. Now, that might be MongoDB, Cassandra, Bigtable, something along those lines. It's typically not an area, a database that you're doing a lot of analytics in. Most of the analytics is done in the warehouse and then copied out and put into the low latency store for access by the application. Then you've got somebody else who's building the back end, and you might do it in Ruby or Python or JavaScript these days. Might be on Rails, Fast API, Node.js. A lot of different ways to go, but you'll be defining endpoints. You'll have a get / my count, post requests, put requests, defining all of your endpoints and what requests they accept. And then you'll have some form of ORM, it's like SQL Alchemy or something, to translate those, build up the SQL, run it across the low latency database, and return the results. Pretty common. And then you'll have your front end application. That might be a web application using Next.js, Vue, whatever it is. Might be a mobile app. Maybe it's not even a front end. Maybe it's a automated system, microservice, something or other, right? That needs access to fresh data. So this is a pretty common pattern. Hopefully that is recognizable. So the way Tinybird fits in this, if we switch over here, is basically between your events and your applications. So Tinybird can handle ingesting streams of data, and you can send your events directly to it. So you don't need any event streaming infrastructure in between. So you don't need to have Kafka, and you don't need to have PubSub. But obviously, a lot of people are already using Kafka and PubSub and things like it. So you can connect those directly to Tinybird and ingest those into Tinybird. Tinybird then consumes those events and stores them in a very low latency analytical store, and then provides you with the ability to run SQL over the top of it to analyze, transform, model, shape, whatever you want to call it, on top, and then publish those analytics, those queries as HTTP APIs straight out the platform, right? So you don't need to go away and pick your ORM and your API library. It's all out of the box. Then you can plug the APIs that you publish from Tinybird straight into your front end app directly. So massively simplifies your stack. A lot fewer moving parts. So that's how Tinybird fits. And I'll just kick straight into actually showing you what that means, and we'll start building this application. So yeah, this is what the finished result is going to look like. So we'll start with this generation mix. So we're going to have to build an API that can give us some time series data, and then also some metrics to fill this area. So I'll come back into Tinybird, And I've already got my Kafka topics connected from doing the little TLDR at the start. But I'll get rid of this little pipe that I set up so that's not hanging about. Cool. So I'll add a new pipe and we'll start building out the logic for our generation API. So the generation mix API. Cool. And I'll just hit run here and we'll see that, we can just query the raw stuff. We're just doing a select star. But I will click on the name of the data source there and it'll just pop the data source preview open to the right so that I can see, a preview of my data, the schema and all that while I'm working on my query. So one thing to note in here is that because it's a Kafka source, I've got all of these sort of meta fields, topic, partition, offset, that I don't actually want, right? They're not useful to my application. So I don't really want to do a select star. So I'm just going to list out the actual columns that I do want. So I've got time from, time to, coal, gas, hydro, solar, wind, other imports, nuclear, and biomass. Now, assuming I've not made any typos in that. Cool. So that's gotten rid of all of the columns that I don't care about. Now, if I go back to the screenshot of the end result, so I want all of those individual columns, but if you look in this metric panel here, I've also got an aggregate for the category. So, coal and gas are fossil fuels. So I want to aggregate those percentages together so that I have a total of how much fossil fuels and how much renewables total. So I also want to add in some aggregates here, which is literally just adding the two percentages together, nothing fancy. So I will do coal plus gas as fossils. And if I run that, cool, you will notice that adding those two together comes out as a float 64 with way higher precision than all of my other columns. So I'm going to come back and change that in a second. Actually, I'll change that now and then I'll just copy and paste it. So ideally, I want that to be a float 32 with only a single digit of precision to match everything else. So I am going to use to float 32 on there, which is great, but then it still has some high precision. So I'm going to do a floor to 1 decimal place. Great. So that's capping that to 1 decimal place and float 32. And then I'm just going to reuse that. And I'm going to do the same for renewables and the same for the other ones. And make sure I don't mess up the commas. So this is going to be hydro plus solar plus wind, and it is renewables. And this one is going to be other plus the imports plus the nuclear plus the biomass. And that is simply going to be other sources. And if I give that a run, I've now got my fossils, which is looking good, the right type, renewables, looking good, and other sources. Great. So that's like, my time series data with all of the right columns. But if I go back to my application, what I don't actually want to do is just show, the entire history, because I think I've got data from 2018 or something in that topic all the way up to today. And I don't really want to show 5 years worth of data in one go. So I've got a little date picker. So I need to be able to take a date in this query so that I can time bound what I'm returning. So normally, you would just do a where, and you would say, I'll do it on the time from is greater than let's say, I think actually we can just do strings. I'm just going to copy that string. And less than this one, which I'll make 0601. So that would give me 24 hours of data, but for a fixed date. Obviously, I don't want it to be a fixed date. So what I need is a parameter, right? I want my user to be able to hit an API, and on the URL they can say, here's a date from and a date to, give me the data between those two dates. So I need to be able to take a query parameter. So to do that, I can use the templating in Tinybird. So I can get rid of that, and I can put 2 curly braces, and I can define a date. So that is saying that this is going to be a date parameter, and it's going to be called param from. The default, I'll just stick this in again as the default. But it's a date, not a date time. The description, and you'll see in a moment that by setting these descriptions, they come through into the auto-generated API docs at the end, which I'll show at the end. So the description, time to start, that'll do. And then I will set it as required equals true. So it is actually required to set that. And then I'll copy and paste that, paste at the end, and make that the param2 and time to end. So if I run that, obviously it's not going to return anything. Actually, if I change that to 0601 there, so that the defaults are exactly the same as they were before, it will return some stuff. But what you'll see at the top is that it's added 2 dynamic parameters, param from and param2, which are both dates. So now when I publish this as an API, I will get 2 query parameters that are a date to start with. There's a comment in chat, but it's not a question. So I've got my query parameters, but one thing I want to be careful of is if they aren't set. So now this isn't strictly needed because I've set them to require true, and I've put a default in, so if they aren't set, then. But I'm going to extend this and add the ability to only return a single row, which I can use for my metrics charts. So I actually want these to not be required if somebody is using this API for the metrics. So I'm going to add in some conditional logic to my query, where I'm only actually going to add this where clause if the dates are defined as query parameters. So I'm going to do if defined param from, and after that line I will end that, and I will copy that same block and add param2, and I'll copy my end. And now this these individual pieces to the where clause are only actually going to get added to the query if they are defined. But the trick, with where clauses is that you've got where condition, and then every subsequent condition needs and. So if you start making these dynamic clauses or conditions in your where, you need to be a bit careful because it can get quite confusing if you have to try and work out where the ands should be. So the little trick is, if you've got dynamic conditions in your where, is to prefix them all with and, so then they can go anywhere in the condition, and then stick a one on your where. So it's where one, and then any optional conditions are just always anded. So that's a little trick for that. And once I've done that, I can order by the time from sending, because I want it to start with the earliest at the top, or at the left. Cool. So that's really all I need to serve the time series chart. But I've also got this this metric one, right? So this will render quite happily, but I want these to be able to say, hey, I don't actually want time series, and I don't want 30 rows or 500 rows. What I just want is the very latest one. So I'll add a condition to my query at the bottom here, and I'm just going to copy that, and I'll say if defined latest. So I'll have another query parameter that's called latest, and I'll say that the latest is equal to true. And I'm going to make this an else, and then copy the end. Right. So if somebody defines the latest parameter on the query, I am going to want to not return a time series, and I'm not going to want to give them the earliest record. I'm actually going to want to just give one row, and it's going to be the very latest one. So I'm going to order by the time from, again, I'm going to be descending so that the latest one is at the top, and then do limit 1. So when somebody defines the parameter latest, which is now defined here, instead of giving a time series and trying to work out what date range should I be from, all it's going to do is get the very latest record. Cool. So that is the logic for that API done. And now to actually publish that as an API, I'll close this little side tab. I can hit create API endpoint. Just before I do that, just to best practice to try and make it easier inside your workspaces is you can name nodes and you can document in them. So generally what we recommend is when you have a node that is the one you're going to publish, you call it endpoint, just so that you know which one is the endpoint. And you can add documentation in here. So this is the endpoint, and then you can actually write something more useful in that comment to actually say what is it doing and try and explain things to it. You can do the same for the pipe as a whole, and you can use markdown syntax in the comments to do formatting in there. So once I'm happy with it, create API endpoint, pick my endpoint node, and I get my API. So I copy and paste this URL, put it in my browser, and there's my JSON result. So assuming I have not made any typos in that, then I should start getting some data in this chart. So this is the live chart, this is not the screenshot. The data that I've got in that topic at the moment stops at the 1st of December of last year, so that I can kick some live data off once the APIs are in, and you can see that it populates. So I'll just go back in time and show you and put the date range of November on. So I can pick a date between, I've got the 1st and 30th of November. That puts it as query parameters on the URL. I've got start date and end date. That's getting passed into the URL. And then all of this is getting returned and visualized. So whenever I change this date range, if I put it to October 31st, that's going away and hitting the APIs, and that is always showing you the very latest, freshest data. So it's going to Tinybird, it's running that query and returning you the results. So as I start to send in fresh data in a moment, you'll see that I can keep refreshing it or showing the next day, and the data is continuously popping in. There's no schedule, there's no lag or latency to it. So that's the first API done, right? I've got my charts powered. I've not had to go away and spin up my own API layer on top of a database. It's all done for me. So I'm going to do exactly the same thing, but for the intensity charts. So if I quickly go back to the screenshot, I've got these intensity charts down here, and they also want APIs. So I'm going to do exactly the same. I am going to cheat a little bit and copy and paste, because it's probably not that interesting to watch me write some more SQL. So I will copy and paste and stick that in. So you can see that this is doing something very similar. The end of it is basically exactly the same. It's got the conditional dates, and it's got the conditional latest parameter to do the same thing. The only difference really at the top is that I am selecting 3 columns, but I am aggregating 2 of them. So what I don't want to show here is, if I show you the raw data, this data source is actually, it's got a row for every 30 seconds. So it's quite granular data. And again, I've got it for 5 years. So it's not particularly useful to show somebody 5 years worth of data with 30-second granularity, because it's just too granular. It also would probably crash my browser if I tried to return 5 million rows onto it. So what I'm doing is aggregating it by 15 minutes. So I'm just going to show 15-minute granularity between a date range. So I'm doing an average over a 15-minute time window. So all of these become buckets of 15 minutes, and these are averages of the raw values. So that's what the query does. I'm going to do the same as I did before. So this is going to be the intensity API, and this is my endpoint. And I'm going to publish that and come over to here, and it all pops in. It can now hit that API. It's nice and quick. Now, if we come back here, what we will see is that the latency of hitting that intensity API was about 30 milliseconds. So yeah, it was fine. But it's processing about 25 megs of data every time you hit the API. And if we go and look at what the query is doing, every time you hit that API, it's running this query. So it's having to re-aggregate by 15 minutes every single time somebody hits the API, and it's hitting 20 to 40 megs of data every time you do that, depending on what the date range is. Now, we probably actually don't need to do that, right? So you can do it, and in some cases it makes sense to do it over the raw data, and it's perfectly quick, but you will probably want to optimize this for efficiency. So what we can do is, instead of recomputing the aggregation every single time, is we can use a materialized view and aggregate, create those 15-minute aggregations on ingest time. And then every time you hit the API, all it's doing is reading the materialized view. It's not actually having to aggregate. So to do that, it's super simple. So I'll create a new pipe, and I'm just going to this piece of the query into here with my group by this time from. So this is just the piece of the query that is doing the aggregation. It's not got the bit of doing the query parameters or anything like that. And this is the intensity average materialized. Materialized is always one of those words where I have to really concentrate on typing it, or it will just come out as a jumbled mess. So this query is just doing the aggregation from my previous API query. But instead of publishing it as an API, I'm going to create that as a materialized view. So all I have to do is on the node, create materialized view, and I'll put the name in there. So it's going to create a materialized view called intensity average MV. You don't have to worry too much for this demo about the sorting key and the partition key. I'm just going to leave them. I'll switch that to yeah, but don't worry too much about those for now. And click next, and then you get a choice when you're doing this of you can backfill the materialized view with a couple of different things. So you can say backfill it with up to 2 million rows with all of the previous rows and then new data. Don't backfill it with any data, only take the new data, or you can write a custom SQL condition to backfill it only with rows that match a SQL condition. I'm going to backfill it with all of the previous data. So I'm going to pick that one, create materialized view, and that's got materialized view. So that's going to go away and process all of that raw data that's already in there and put that into a materialized view. But the thing about materialized views in Tinybird is that as new data is ingested, as new data comes in, materialized views are kept up to date as a new row comes in. So there's nothing to schedule. You don't need to go and say, hey, rerun this materialization every night. It doesn't it doesn't compute the entire table again every time. So they are materialized incrementally. So as you have a new row come in, it works out, hey, which part of the materialization does this row affect, and then goes and works out what the incremental change to that particular piece of the aggregation was. So now that I've got that, that's just going to keep going, and as I add in new rows, it'll be kept up to date. So in my intensity API, I don't actually need to work out what the I've just noticed that I made a mistake in my materialized view, which I'm happy I caught. So I'm going to unlink that. And at this point in my materialized view, I don't want to start changing the types of the data outside of my aggregation. So I'm actually going to delete my materialized view and recreate it. So all I've done is taken out the toInt and just left it as the raw average. And I'll recreate that materialized view. Luckily it's super quick, so I'm not too concerned. So I'll recreate that, all previous, new data, create that again. Cool. Right, so back to where I was. We've got our materialized view. Now, in our API, instead of calculating the raw, calculating the average over the raw data, I'm going to use the materialized view. So I can just update this to be intensity average materialized view. Now, the thing to be aware of when you're using materialized views is that because of the way that it incrementally updates materializations, there are incremental states kept in the materialized view. Now, I don't want to get too much into this because there's not that much time left. But effectively, you need to replicate what the aggregation is in your query, but using a merge suffix so that it knows to read the incremental states from the materialization and combine them down into the end result. So all we do is add merge at the end of average, and I will leave my 2int16 in there so it formats them as I wanted. And if I run that, pay attention to this number here. So that was at like 38 meg or something, and now it's down at 10 meg. So just by adding a materialization into the pipe, I've pretty much reduced the amount of data that's processed by 4 times or something, and that took me 2 minutes sans messing it up and having to do it again. So it's a pretty decent optimization to be able to do super quickly. And if I come back into my API and go back to here and refresh this, it all works exactly as it did before. This is now just reading the data from a materialized view rather than calculating it raw every time. And that's pretty much what all I had. So you can see here that the process data has gone down from whatever it was, 20, 25, 24 megs, down to 4, which is well, you see here it's a 83% reduction. And you can see on this little timeline of the effect that my optimizations have had. Now all of this as observability data is available to you. So it's kept in a data source in Tinybird, and you can write pipes to query your own observability data and publish those as API endpoints. And if you want to, stick them into your favorite monitoring tool of choice, like Grafana. And it just so happened that very soon we will be releasing and doing some announcements about our new Grafana data source, so that there will be a native data source for Tinybird for you to integrate with Grafana. So that's pretty much everything I had to say. I see there is a comment in chat that I wish I had seen earlier. It says the text was too small and I should have zoomed in, which you're right. I forgot to zoom in, which is unfortunate. I'm not going to start from scratch and do another 40 minutes just with it zoomed in, but yeah, noted. So if there's no more questions, if anyone's got questions, feel free to pop them in chat and I can stay on and answer. But if there's nothing else, then I will end the stream there. Okay. Well, thank you. And the recording will be available afterwards. And please do go check out the GitHub repo if you want to download it and push it into Tinybird and give it a go yourself. Thank you.